Hi, Jacob. How are you?
Good. Yourself?
I'm good. This is for everyone who's watching this video. This is Jacob. He's from Cloudflare. I'm John from Octopus Deploy, and the two of us have we've been talking to each other on Twitter, sending complaints about things like that we're dealing with around Terraform, etc. The two of us have worked on our associate of Terraform providers. So Jacob is the maintainer of the Cloudflare Terraform provider, and I've worked a lot on the Terraform provider for Octopus. And in this video, I thought that it'd be kind of fun for us to kind of compare notes and also talk about the new plugin SDK that hashicorp has announced. So for those of you who aren't aware, there's a number of ways to build providers, and Terraform now has a new one called the plugin SDK. And I thought, who better to talk to about the nuances of the SDK than someone like Jacob? And so thanks for joining me, Jacob. I appreciate it.
No, that's all good. Appreciate it, and really appreciated the support group we formed around the problems we've hit and the techniques we've taken.
That's right. So before we kick things off, maybe it might be a good opportunity for us to talk maybe a little bit about Cloudflare, and give us I know about Cloudflare, you know about Cloudflare, but for folks who don't, maybe what's the elevator pitch there?
Yeah, so I think the landing page does a pretty good job of like an overview of what Cloudflare is. It's now a global network of things that run. It started off with web application firewalls and CDNs and all those nice sort of things, DDoS protection, and all that sort of thing. But now it's got things like Cloudflare Pages, which allow you to host static sites. There's durable objects. There's workers, which a lot of people will be quite familiar with. And yeah, we're even doing a lot of stuff around the zero trust space. So if you have some on-prem side of things where you have, boxes sitting in a rack somewhere, you can use an agent to connect remotely and securely to the network and not have to handle all that gross middle stuff.
Nice. And so for those folks who aren't aware, you can use Terraform to manage various parts and pieces of Cloudflare. Is that right? Of course, I'm sending you softballs here because I know the
sure.
But I want people to understand kind of why we're talking about Terraform in the context of Cloudflare.
Yeah, so if you haven't used Cloudflare, the services that we use are all exposed via APIs. So if you need to add a DNS record or you want to change a configuration option, they're all publicly available via our API. The good thing about this is that it's super customizable and you aren't locked into like what's the best way, like a proprietary API or anything like that. It's just JSON. So we can then build tooling around all of that. And one of the tools that we invest quite heavily in is Terraform. And the reason for that is that the 101 of Terraform is that it's essentially a HTTP client with lifecycle management strapped on top. So what that allows you to do is say, you need to manage DNS records. Instead of you writing 4 or 5 different curl requests or doing something with your own HTTP client, you write HCL, which is their configuration language, kind of looks like JSON with less quotes. And that is then translated to API calls. Once the API calls are made, you can do things like store it in the state, maintain the life cycle of it, all that sort of good jazz.
Yeah. The way that I've defined Terraform is it's like the Genesis device from Star Trek II, The Wrath of Khan. The idea is that you can shoot this missile at a planet, which is your target, like AWS or something, and you can destroy the entire planet, and then it will rebuild it from scratch. And then essentially it's an aptly named product, Terraform. If you think about how you terraform a planet from a desolate wasteland, i.e. Google Cloud Service, Azure, whatever, Cloudflare, for example, or Octopus, like a bare bones instance. You've done the next finish of installation. Now you want to configure this thing, and you want to share the state between what you see the world as and what the remote world looks like. Terraform is a tool that allows you to do that, and you express that, as you said, in a JSON-like structure called HCL. And incidentally, HCL is the fastest growing programming language on GitHub.
Oh, really?
So yeah.
Geez, that's sad.
Sorry.
It's
I
it's
thought I'd just throw that in there. Yeah.
Yeah, one of the, I think he's the lead engineer for Terraform now. He actually did a really good write-up of why HCL and not other things.
Yeah.
And it's actually very, very extensive as to why, like, I don't know, JSON or something else doesn't quite fit the bill. And
Yeah.
if you haven't seen that, I highly recommend going and reading it, because this whole time I was kind of like, well, did you really have to invent your own? And did you have to confuse people with your own types and stuff like that?
Come on.
And
come on.
yeah, and like you read it and you're like, he's got a pretty valid point. And it's a very well-written article as well.
Yeah. Anyway, enough trashing of Terraform. We both love Terraform. I mean, we both maintain providers, right? So we shouldn't trash it too much. We trash it because we love it. But this is the Cloudflare provider. And the thing to understand about providers, and we'll quickly, I know people who are watching this video who have done provider SDK work, they're like, get to the point. I'm like, fair enough. So providers are generally contained within two types of resource types. There's data sources, which are basically like, I want to do a read operation. I want to get some data from the remote state, and I want to put that in some kind of entity that I could query. That's what a data source is. And then there are resources, which is where you perform your CRUD operations. So if you want to do anything with Cloudflare, for example, if you want to say, register a new account, or you want to create, whatever, like WAF rules or things like that, what you'll do is you'll write that in HCL, kind of like what you see in these examples here. You'll create resources which are in local state, and then you'll run the Terraform CLI against it, and it will do a diff, and it will say, hey, what does a remote state look like, etc. And then based off of that, it will then perform API calls on your behalf through that tool, thus Terraform. So Terraform is basically a way of expressing intent in a declarative manner, i.e. via state, that will then impact remote services through API calls, which is why we mentioned the APIs in the beginning. Now, just as incidentally, we also have APIs for Octopus as well. So if you take a look at Octopus as sort of another comparison here, I love how people are taking AdWords out on Octopus for other things, but we have a REST API as well. And we have a bunch of examples, and we talk a little bit about how you can talk to Octopus in many different ways. We have lots of different resource types. Resource is a generic term to just say something like an entity, like something that you work with on. In case of Cloudflare or Octopus, it's something that you work with, and so these are mapped typically to resources in Terraform. That's typically how you'll organize your Terraform provider from a code perspective, and so. These sort of resource types are also mapped in Cloudflare and its API. And then if you take a look at the docs, these ones typically map one-to-one. Jacob, I know you've done all this, but like I just wanted to take the chance here to demonstrate that I know something about Terraform. So is the summary I provided accurate? Is it somewhat right?
It is far more extensive and far better worded than what I could come up with.
Cool. So you've got quite a few users. I noticed that you've got 38 million downloads, 34 million downloads. Sorry, that's quite a number.
Yeah, I don't really like the statistics on the registry as
come on, you got to have a little bit of a casual brag, a humble brag. So there you go.
It is something that's definitely increasing. We're seeing with the user bases, and
yes,
it's not just like big orgs that are coming out and saying, hey, we have really strict compliance requirements. It's people like me that have home labs, or people that are running side projects, and they're like, I just don't want to touch the dashboard, or I don't want to play with the UI, which is like in general one of the big selling points of Terraform. Is that you can take anything with an API and codify it. Yeah,
agreed. So the nice thing about the provider structure is when you build these things out, so a couple of things that need to be explained. Terraform is based on Go. So if you're going to write a Terraform provider, you pretty much want to build it in Go. You don't have to. You can write providers in different languages, but you really should be doing it in Go. And so that behooves you to have an API client in Go, and also think and Go and all those Go-isms. So far, so good. Yeah, we're good with that summary.
Yeah, I was waiting for you to insert "you're going to have a bad time" meme, but yes, that didn't happen.
Yes. So you guys have an API client, I assume, for Cloudflare.
Yeah. So this is another one of my lovely things. Is that we have a Go library, and that's mainly where we invest a lot with our SDKs. We do have PHP and Rust, and there's work coming to make those like more, I suppose, more coverage of the public API. But Go is the main one, and the large reason for that is like we just have such a massive surface area.
Look at this.
Like imagine doing this for like Rust and for PHP and all those various languages that people want to use.
Now, I have to say, Jacob, I'm incredibly disappointed that you guys didn't come up with a Cloudflare Gopher mascot for your Go library, because we did. We did one for ours. So if you take a look at our Go library, we decided we got to have one. So there's ours.
That's unreal. I might just have to like hit someone else to do one of those.
So you need a Cloudflare. Everyone needs a Gopher mascot for their Go library. So
yeah.
All right. So anyways, you need a Go API client because it's going to make life easier for you. And then until recently, which is the whole point of this video, we're providing context here, but until recently, you would have to target what's called the Terraform Provider SDK, which I'll just quickly Google here. So that's the plugin. That's what we're going to talk about. Sorry. God, do they even have it linked in anymore?
No, that was the right one.
This one?
Yeah, the first one was right.
Oh, you're right. My apologies. Sorry. Yep. Sorry. I see plugin SDK, and I always think of something else. So anyways, the SDK, V2 of the SDK, there was a V1, and then everyone went to V2. And this is basically what it does. It provides the basic building blocks. It's basically a contract that's defined for when you write a provider. Here's what you have to do. Now, you may ask yourself, why write a provider in the first place? Well, Terraform doesn't know about every single service on the planet. They have ones that they know about, like Amazon Web Services and Azure and all that sort of stuff. Like if you go to the registry, for example, you take a look at the top ones that are listed, right? These are the ones that, the HashiCorp maintains a lot of these themselves. But if you're a service out there, like if you're an ISV watching this video, or if you're a general user and you're using a favorite product, let's say you're using something like, I don't know, Sitefinity from Telerik, or you're using some new framework from Microsoft, or some library that's out there that you not a library, but you know what I mean, like another service that's used by, and there's no one out there is actively writing a provider for it. You have to write one yourself, basically. This is the extensibility model that's built into Terraform. And so providers provide that level of abstraction on top of Terraform to talk to those services on your behalf via Terraform. And so the reason why you have to target this framework is because it provides that mechanism for you to hook into Terraform. So this is how plugins operate, essentially. Which brings us to the whole point of this conversation. We're already 13 minutes in, and we haven't even talked about the plugin SDK, which is why we wanted to talk anyway. So, the plugin SDK, and this is where my headphones start conking out here. So I'm going to switch headphones quickly here. This is fun, eh? Like live. I'm not going to. I'm not going to stop the word here. I'm going to put my here. Watch this.
How about I'll give you a rundown of why the plugin.
No, we're good. Go ahead, please. Yeah,
because I was going to say this is something that a lot of people don't realize, but the internals of the Terraform plugin ecosystem have evolved a lot in the last. I'm even going to say last 3 years. So previously, everything was within the SDK. So you would have all of your validation and all of these different sorts of things, all of your logging, all of blah was all inside of it, and it was a monstrosity to actually work on because you would go to run test suites, and there was just so much that would have to happen.
Yes.
I don't know where it got to a point, but there's a lot of the early Terraform engineers that I've spoke to over the years that have just been it was really hard. They hit a sort of critical mass where it was you know what, we need to start breaking these things off into plugins. Not everyone needs everything that's involved with it.
Yes.
So the first version of the SDK was largely like that. V2 started breaking it apart and getting to the point where you didn't need as much, and you could do things optionally. We then got to the point where I think it finally tipped, and they're you know what, we can't keep carrying around the baggage that the SDK V2 has. We're going to break this new thing, and it's called the Plugin Framework.
But also plus there were things that you just couldn't do in the SDK V2. There was things I was tearing my hair out about things I wanted to do with the plugin SDK, and they're like, yeah, that's not supported. Like a perfect example is when you write a state file, not a state file, sorry, a config file, and you're deeply nested within that config file, and you're writing the schema document for it. And you start putting in validation. That validation only works at the root level. So you have to navigate all the way back up the child or the tree structure basically, and then put these rules on. And then in some cases it wouldn't work with nested attributes. And you're just like, come on, like this is so frustrating. Like, okay, so we're okay. So we've done the intro. Now, anyone who's watching this and has not done Terraform Provider logic before, you're gonna have a bad time from here on out because that's all we're gonna talk about is basically Terraform providers. But sorry, I interrupted. Go ahead.
No, that's all right. And I was just basically going to say is like the plugin framework. One of the good things about it is, and you know what led to your comment was that they're able to clear out the years of abstraction and compatibility layers. Yeah. So unless you've delved with the internals before, you don't necessarily realize why these things were problematic.
Yes.
And it's like, well, at the end of the day, everything in Terraform ends up as like an interface, and then they've like got this types library underneath that does all the conversion and the checks and so on and so forth.
Yeah.
So it was good. Like I'm sure they still use it. I haven't delved into the framework that much because we're like in that process at the moment.
Yeah.
But like it was good to be able to get to the point where it's like, hey, these weird rules that used to exist are no longer there, and things actually function.
Yeah.
So like in comparison to like V2, some of the things that like I've really noticed is that it feels more Go-like. So if you write Go, you are going to be a lot more at home with the plugin SDK than, the plugin framework. Oh, God, this is going to get so annoying than what you were with the SDK V2.
Yep.
Because a lot of Go users aren't expecting to be doing like typecasting and all that sort of thing everywhere, whereas Terraform really hangs off it. One of the, I know you mentioned validation as a bit of a pet peeve for you, but like one of the big things that like we're still facing with the SDK v2 is the ability to tell whether a value is null, unknown, or a default.
Exactly. And all those things. Yeah.
And it's like, it's one of those things that you think about and you're like, oh, that should always be okay. But it's really hard to get right with the SDK v2. And in some cases it's impossible. And that was why we ended up on the plugin framework.
Yep, same. So for those who don't know what we're talking about, so Terraform now has, HashiCorp has now published the new Terraform Plugin Framework. So this is HashiCorp's now recommended approach to doing plugin development via providers. And what's interesting about this is that they're starting to expose parts of you're starting to see how some of the sausage is made relative to Terraform itself. So folks who didn't know this before, it actually has a protocol defined that's done via protocol buffers. And that's how basically Terraform and providers talk to each other. But you were never exposed to that before unless you went deep down into the guts of Terraform. And they're bringing that a little bit up. They're bringing that a little bit up the stack, which I think is a good thing. They're kind of giving you more control over that. But the new plugin framework has a bunch of benefits over the old SDK v2 work. And I thought that, now we can kind of talk a little bit about what those things are and kind of how they work and how it all comes together. Because the reality is today, if you're going to do this today, and I know that I'm hoping that some other provider authors are watching this video. Jacob and I struggled with, like, over Christmas, we were tweeting each other like, hey, have you figured this out? I'm like, no, I'm just figuring it out right now. And like the docs weren't super clear on how to do certain things. We were like, all right, let's figure this out. And like, I just bang away on the keyboard and eventually got it to work and kind of like, figured it out after a while. But I thought it'd be interesting to talk a little bit about some of the capabilities of the plugin framework, some of the gotchas and things like that. So, so the plugin framework is just yet another Go library. You just, get and install, and away you go. And but what's really nice about it is that, as I said, and as you said, there's a whole bunch of new features in there around its API surface, its interface constructs, etc. First and foremost, the thing that you're going to fly right into is obviously muxing. So should we describe what muxing is?
Yeah. So I'll use its full term here: multiplexing.
Yes.
Because if you're outside of the Go ecosystem, like there seems to be different names for this, but multiplexing seems to be the consistent thing. And this leads really well when you mentioned about the protocol that the providers are using. So the way that a provider works is that it's essentially a server, and it back and forth with these protocol versions and conversations between that and like the client, which is the Terraform CLI tool that most people use. And
or cloud or whatever.
Like there's plenty out there that you can do with it. They're just not all like complete. So there's very like proof of concept where you like can do like middleman logging and stuff like that. And it's a little bit janky, but like it works. Terraform and like cloud is definitely the two big ones. And like outside of that, I probably wouldn't bother speaking to anyone else about it because they're all too jank. But in protocol, the SDK v2, they were using version 5.
Yeah.
Now it's not like one of those massive everything broken between version type of changes, but there are a lot of like things that have changed that make it significant enough that you need to be able to run one or the other. Yeah. And in the case where someone else is developing from SDK v2 to the plugin framework, you either have the option of migrating everything at once, which for 95% of people isn't going to be possible.
No way.
Or you can do what is called multiplexing, where you take both versions of the protocol and you combine it into one and expose it as the higher level. Luckily, HashiCorp do a really good job of providing that pathway.
Yes, totally agree. I thought this was when I saw this, I was like, yes, this is awesome. It works great.
Yeah, initially when I went through the docs, like I couldn't find where they were doing like the conversion. I was like, oh man, please don't make me do this. Please don't make me do this. But I managed to find it, and I was like, yes, this is so good. So the way that you end up doing it is like you have SDK v2, which is v5 of the protocol. See how many times I say V in this sentence, but v5 of the protocol, you then upgrade it to a v6 protocol server, and then you multiplex the two of them together and serve one unified v6 interface, which is actually quite sensible. I was expecting this to be far worse than what it was, but once you get it together, it's very straightforward. So
just take a time out from, I don't want to interrupt you too much, but just a time out on this. So if you're a provider author watching this video, this is the first thing that you're going to want to think about. Before you can do the hello world stuff to figure out kind of how do the APIs hang together, and that's fine. But at some point you're going to want to start converting resources over. And generally that's when people kind of think, I don't want to do an all or nothing. I want to do it piece by piece. And this is where you're going to fly right into multiplexing and combining providers. So as Jacob said, SDK v2 runs protocol 5. Chances are you're going to want to use protocol 6, which I think is Terraform 0.12 and above, or 1.0 and above. I can't remember which they talk about.
I think 1.0. Right,
Sorry, it's right here. Sorry. Sorry, not there, but they talk about the protocols and where their support is. So what this basically means is when you have a provider, you have all these resource types and you have all these things that do your translation. You don't have to go all or nothing. You can convert one and then use the multiplexing, muxing, whatever you want to call it, to basically do the translation between those communication providers, basically. So you can host the two providers in the same space, essentially. And the way you do that is you'll download this plugin library, and then you'll utilize the Mux Go module for doing the multiplexing on your behalf. And I think I actually have a code example. We can quickly look at this. Obviously my code is in a bad state here, but I'll just quickly show you folks kind of where this kind of hangs together. Oh, good. Here we go. This is where I'm going to jump around and try and figure out where I am. So I converted one for Octopus Deploy, which is for our environments. This is what a typical, so you see all this data source / resource stuff. This is what you'll typically see in a provider, like a V2 SDK provider. And the muxing that I did for this, I believe, is in my root level file here called Octopus or Provider.go. No, it's in Octopus.
I was gonna say I had to do mine in the main.go.
Yeah, you might be right, actually. No, you're right. Sorry. It's been a while since I've looked at this. Yep, you're 100% correct. Sorry, my apologies. So, all right.
I was like, oh shit, is there somewhere else?
Sorry.
Do this?
Sorry about that. Yeah. All right. So here's main. So the first thing we'll do is this is a pattern you'll see a lot of folks do is kicking into debug. This is a pattern you saw with the old SDK v2 provider framework. But the first thing you'll want to do is there's a Terraform 5 to 6 server type that is part of multiplexing. You can do an upgrade server, which basically wraps your V5, provider into a V6 server. The reason why I do that is because I just wanted to go V6. I'm like, I'll just go V6 the whole way. So what I do there is I provide the provider, the old provider that I have for that, which is this one here. And then you also host a V6 provider, which is the new one, which is the one I have that I'm working on right now. And then at the end, you combine the two, and then you serve it up using those options, basically. So that's the whole purpose. This is the first thing you're going to do when converting resource by resource. You need to have this bootstrapper, basically, this bootstrapper code to get things going in order to do the muxing, multiplexing for you. But sorry, I interrupted you again. I apologize.
No, I'll rant about this for far too long if people don't. So I was going to say, so like in terms of people that already have a provider, like I think even HashiCorp make like a good overview of this, but like what you want to do is make sure all of your tests are passing.
Yeah.
Then we go through and you implement the multiplexing, and like at that point you should be able to run the test again and have no failures. It should like just work out of the box.
Yes.
If you don't have it at that point, there's something broken with the multiplexing. So like I'd recommend doing those before you go through and like play with the provider definitions or like any resource definitions.
Okay.
Like get that working first. Just because it's a really like bite-sized thing that you can do. And then you can go down the route of like adding the other provider and so on and so forth.
Yeah, cool. So I assume you have a similar type of setup in your main for Cloudflare, I assume. Is that correct?
Yeah, I think, if you hit the files change, I think it should just be like the only change in like the main.go. This is probably going to take forever to load. One, because we're in Australia, but also it's a massive PR.
Don't worry about it. Actually, it's probably at the bottom here. There we go, main. Okay. So if we go to main, which is going to load eventually, load the diff. Here we go. So, yep, it looks almost identical. Yep, to the code that I wrote, pretty much.
Yeah, and HashiCorp do have some good docs around this.
They do. They did a really good job of this. Yeah, you can see the difference here. Like everyone did this back in the red side. Everyone would do this like, if it's debug, okay, loaded debug mode. Otherwise, we're off to the races. Now it's more like, no. We've got two different types of providers here. We got to load them up, translate, yada yada yada. So there's going to be a little bit of this code kicking around. If you go on GitHub and search for code examples, pretty much every provider is going to have this now. This same sort of bootstrapper code now for a provider.
Which is like another thing that I don't think a lot of people realize is there's a Terraform plugin scaffolding.
Yes.
Which is essentially like an example, and they have it for V2 SDK and the plugin framework.
Terraform, sorry, it's HashiCorp.
Yeah, it'd be under HashiCorp. Yeah, the Terraform.
And yeah, then they have the
scaffolding.
They have a scaffolder. I remember looking at this as well.
Yeah, and it's actually really handy when you are trying to find examples of how things should be structured or how you should go about things. There's also another one, which is the Terraform Provider. I think it's called Corner or something like that, where it has all of their weird edge cases for provider setups that, this is it. So if you go into the internal, I think there's subdirectories there so like if you're wondering how to do like SDK v2 or like TF,
nice.
yeah. So
I hadn't seen this. Is this new? I haven't seen this.
I don't think so. It's been there for a little while.
Okay.
But like, yes, it is only their corner cases of setting up providers and stuff like that, which was I actually used initially before like the docs got a bit of a revamp around like how to properly put these together and like whether I wanted to use one version or another. Yeah, it's very handy.
I like it. So there's the corner repo you can check out. Don't go to Terraform. That's a different org. And then there's also the scaffolder, which is basically going to bootstrap you into creating a new provider. We should clarify this is for the new plugin framework, this one.
Yep. Yeah, there is one for SDK v2, but if you're writing anything new, don't spend time with SDK v2. Just go straight to the provider frame.
And this is also important. This catches out some folks. I think you're running on 118 and higher. I think we're running on 120 now. I mean, 120 just recently came out, and we just upgraded. It's not really a big deal, I find. So
yeah. So with Go, it's nice that for the Cloudflare provider, we basically do the current version -2, just following the upstream policy for that. But the good thing is once you like build the binary and people are using the binary, it doesn't matter. Because it's all packaged anyway. It's only sort of a problem if you start developing against it, which another pro tip, if you are doing the plugin, the provider at all, please provide some sort of local development and testing approach. I've gone with the VS Code Docker dev container approach. But I'm also playing with a tool called Flocks, which is based on Nix, and that side of it is also super cool. Just to be able to say one command, have a local working environment. Especially with things like the debug. So again, getting back to history, debuggers in Go, like Delve, never used to work. And you were pretty much restricted to doing like logger-based debugging, which really sucked because you needed to know where the problem was. But since the debug side of it has all improved and it now supports Delve.
That's something I've noticed as well. Sorry to interrupt again. When your provider crashes, you get that massive like panic and stuff, and you get this huge stack trace. And if it's deep enough within, so particularly when you're doing your flatten and expand within it, we're getting super into provider talk now. So when you do flatten and expand and things crash, you're like, oh my God, where do I begin? Especially if you're deep in an expand. If things crash in your expand, the most you'll get in the stack trace is the root level expand. You won't get the nested within nested expand call. Like that's the way I structure my provider. I don't know how you did yours, but I know that if you have certain elements that you then call a different expand function, if you're at least one level deep, good luck finding the source of the problem.
Welcome to Go.
Yeah, exactly. Cool. So I can show some code examples unless you had some that you wanted to cite around the plugin SDK. Did you want to go back to your pull requests and show some examples there?
Yeah, we can set through a couple of them.
Do you have one that you like? You thought I did a really good job of?
The only sort of thing I would touch on with the migration is that we took the opportunity to restructure the directories as well. So as you can see on the left-hand side here, it is an absolute mess of just like one big files.
But you moved them around, right? You put them into subdirectories. Is that correct?
Yeah. So if you don't already, please use an internal directory for your resources. Don't allow people to try and like do weird things with it. But I managed to split things like I'll touch on this in a second, but like our constants that we use within both providers, the framework and the provider, the SDK v2 provider, as well as like some utilities and that sort of thing.
Yeah.
And largely, which I'll now come back to, but like when you start developing the provider schemas across both versions, they have to be identical. And if they don't, they throw an error and it won't compile. So this was why sort of opted initially to do like a constants package and like a framework package and those sorts of things, so that we could keep them in sync as much as possible. It's a little bit annoying because you get into a situation where you're actually defining the schema multiple times and you can't reuse them. So in the SDK v2, the schema is basically a string to object type of mapping. But then when you start getting into the framework, it is a string value, but to a specific type of whatever you're using.
So that's good. Let's talk about schemas then, because that's probably the first place we can start with the plugin framework. So in terms of one thing I will say, just as a side note, so they do a wonderful job of documenting this is way better docs than what we had previously. So they go into deep detail as to how to generate or create a call for creating resources, reading resources, updating, deleting, etc. They also go into quite a bit of detail around defining schemas as well. And they talk about specifically, and this is where it gets a bit interesting, they talk specifically about the types that you can use and the new types that are provided, as well as the functions, et cetera, et cetera. So this you'll find in the handling data section here, and they talk about schemas, and they talk about, okay, these are the types that are available. This is the breakdown of everything you have to use, and yada, yada, yada. There's a validation library as well. And then they talk about different things, like there's different types of blocks that you now have available. There's subtle changes to the block definition type. But when there's a table that I'm particularly looking for here. Let me see if I can find it. They talk about conversion rules. If you've done any work with providers, some of these will look very familiar. But like you said, in the provider, it's mostly just strings, and good luck trying to figure out where things are. But they do have some other types. They have some other types here for things like detecting if it's been nullable, etc. Let me see if I can find the tape. This is kind of what I was looking for, some of these tables that they have. So these are the new types that they have defined for attributes and blocks. So they have specifically, when you define a schema, you'll have two sections, one for attributes, one for blocks. That is new. They didn't separate those before. And before, you had a schema, you just define the schema and you say key value pairs and away you go. Now they separate the two and they give you specific types for defining those things. So these are attribute types for attributes on your schema type. And then these are block types that are defined for your blocks within your schema type as well. To give you a code example here, I know of one that I've written. So if I go into my schema here, you can see that I have a bunch of, like, this is the way that you'll typically define a model. This could be anything, but I define it as a model. And they're utilizing the new tag infrastructure from the Framework SDK thing. So this is nice because typically you'd have to hand roll this yourself. Now what you do is you use their type library. It's called types here, basically. This is their type library that they provide for specific types in Terraform. So you denote what kind of type this maps to. The reason why they do this and why they don't use native types is because there is a notion of what is null, what is undefined, etc. And those things don't carry over because by default, a bool is false, or by default, an int is 0, that sort of thing. But you have to have those things carry over because in state, you can have a null type as a value in terms of remote services, for example. That could be a valid description. The nice thing here is the fact that we have struct tags here allows you to define how these things are emitted when serialized. And so you can define these things as part of the schema. So this is what ultimately emits as part of the schema. So when you write out schema for this model definition, and you have a property here called allow dynamic infrastructure. This is for Octopus, by the way. This is how we'll map that property, or this property for this struct, to this value in state. Did you want to talk to this at all, or did you guys do this as well? Or
yeah, like I did. So we're in the process of converting like one of our biggest resources at the moment that is like the most problematic. And the thing that kind of got me here was the amount of duplication that you have to do.
Oh, sure.
So,
yeah.
So like you have to do the model and you have to still define the schema. There isn't a nice way of saying
reflecting it.
Yeah. And like I hope that they improve that in the future, because this is honestly one of the biggest pains that I'm having at the moment is just the amount of verbosity. And your schema looks much nicer than what mine does. I think Like if you check out my PR that I think I don't even have a PR for it. It's just a branch.
All right, let's go. Let's see where the bodies are buried. Here we go.
Yeah. So go go one tab over.
Okay.
Yeah. So this one. So this is skip the first one. Blah, blah, blah. But like this here is where we start getting into it. Yeah. And so this resource has like, I don't know, stupid amounts of nesting, but I've only added, what's that, 10? 6. I've only added like 6 or so attributes on there, and look at the size of the schema now.
Yeah, it's getting pretty beefy. I rolled these into functions on my side. So I wrap these up into functions because I hate seeing a huge description like this. This seems to be the norm with provider development. When you look at providers, especially when you look at people's schemas, it's like page down, page down, page down, page, and you're just going through reams of schema. And I'm like, I don't like that. So I wrapped a lot of that stuff into functions because I have a lot of our API tends. I know a lot of people's API tends to be consistent. So if you say it's typically going to be this, then you can wrap that in a function. Just assume, okay, the only thing that's changing here is the actual name of the element in the schema itself. Everything else is the same. So it looks like there is some commonality here that you've got. The only differences are things like required versus optional and the validators that are in there. And then sometimes the markdown description is kind of generic as well. Like, this is a zone ID. All right, this is the zone identifier. It's like, what else do you want?
Yeah.
You know?
Yeah, and like it's definitely something to consider here. Like a lot of our resources have varying, what's the correct term here? Schema structure. Yeah. So as you just mentioned, like some of them are required, some of them are optional, and like name may be used on 20 of them. And like you end up with functions that like name that is required or like name that is optional. And like maybe that's a way of doing it.
Let's talk a little briefly about, sorry to interrupt, I'm just seeing these things again, and I've done this myself, but I just wanted to, if you have any comments about plan modifiers, I think they're really cool. I think this is one of the cooler parts of the new SDK. The new SDK. What are your thoughts on plan modifiers?
I like them largely because it makes your schemas and your code more Go-like. Yeah. So if you were doing this with Go outside of Terraform, that is almost like how you'd expect it to like how it would be, short of having like method receivers and those sorts of things. But
so we should describe what plan modifiers are. That the way I think about them is that they are basically an array of things that you want to happen during the various stages of a Terraform operation, whether it's a plan or apply, etc. And then they have various side effects that can occur based on what they actually do. So in most cases, you'll have a plan modifier will do something after the fact. And that differs a little bit from validators. This is more of the traditional thing that you'll see within SDK v2 provider, where it's like this one's required and it has to have a lowercase first letter, blah, 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 like those little functions that you would write back in the day. Validators operate in the same way. It's an array of validation that can run. And then you have these sort of rules that can apply against those types. Sorry, that's the way I've looked at these things. But did you have anything you wanted to add on to that?
No, that's great. The only thing I would say is like I much prefer this over the previous behaviors, largely because it was very hard to, like when you had things like customizing the diff or things that were like a little more involved. It received a function, but there was no way of saying run multiple of these small things in order. It just had to be one function. Whereas now what you can do is say, all right, I can have a validator that does like a conflicts with and like a requires as, and they run, and you can see specifically what it is. Yeah. Plan modifiers like stretch that even further, where they say like, these are the 5 things or the however many things that you want to run when the plan is in operation, or like when an operation is going.
Yeah. So this is for a schema, and just to reiterate, we have our attributes collection, then we have our blocks collection. So blocks there's a new type of nested block, I believe, if I remember correctly, that requires an equals, and it's a protocol v6 ism that is now available. But generally speaking, blocks are easy to define. Like you give it a name, you define what kind of block it is. So you'll have like object nested block, list nested block, set, etc. And then inside there, you've used the nested object here. So any comments about blocks, the minor tweaks that are there?
It's definitely a change for a lot of people, but I feel like it's less of a change for myself, largely because I worked with the Terraform internals. So when you spit out I think it's Terraform providers -JSON or whatever, and you spit out the structure of it, this matches far closer to it than what we previously did. So there's no more like weird abstraction that you have to work out. Like, oh, this is like a block, and then there's other things that go underneath.
Or I have to use that dot notation. Yeah, if you wanted to hard code a reference, you could. You could always be like, if I'm in a nested block, I could be like foo.0.bar.number equal, like it's like, all right.
And then like asterisks for sets.
It's like regular expressions now. It's getting kind of convoluted. So yeah.
That's another nice part of the plugin framework is they now have this like path concept. So you put in the value. I think there's even some here. Where you can put in like the path expression. There you go. And like you can determine whether it starts from the root or whether it starts from the current level, which is great because when you're like, let's say you've stupidly designed a schema that's like 5 nested levels deep, you're not having to traverse from the root. You can say from relative attribute.
This thing, especially in the context of validators, is like, I think everyone asked for this, is like if you have a deeply nested block type and it's got its own sub attributes and sub blocks and stuff, and people wanted to put validation against those, but it was almost impossible to do that. Now that's all gone away and it's available as a validator, which is like, thank God, because like for the longest time it was so frustrating. Like, well, I would put validation there, but it's just too hard. Like we don't know where we're at in the tree structure, so it was just too difficult. And so now, now we can just make it work. Pretty easily
and like and much to like, I know people throw shade on like open source maintainers for like not being able to break and change things, but like in a lot of cases, the Terraform folks' hands were like very much tied. The way that the SDK v2 was architected and the way that it was built made making some of those changes very, very difficult. And like, just to give you an example, like the zero values thing, you don't realize how hard it is to determine whether a value was ever null or never like unset, or whether it was like false in the SDK v2. And it's not because like people are incompetent. It's because it would go through like 10 layers of abstraction, and each one of those abstractions were like checking different things, and to unify all of them would actually break most functionality that people are relying on. So
it was just a lot of work for very little. It was very little bang for buck, basically.
Yeah.
So you're like, whatever.
I think it sort of just got to the point where it just tipped over, and they're like, we need to do something better with this. And shake the past, but it's really good. So big props to them.
Yeah, agreed. So just coming back here, because this is where I spent most of my time, was in the docs here. They talk about, so how do you do a create? How do you do an update? That sort of thing. So they define their schema. You use the tag, the struct tags, and away you go. And then in here, it looks largely the same. Now they have a lot of ceremony around diagnostics here. This add error, I'm not a huge fan of. So they have very, very verbose error types in the new plugin SDK. Any thoughts on that quickly?
I would much rather, like when I use diagnostics, I generally only give it an error. Like
I know. Everyone just returns E, and they're like, just return E. I'm happy, But now they've got this new add error thing. You have to like give it a summary and a description, and everyone's like, ugh. It's like docs. I don't want to write this,
I do like the way that it ends up formatted when there is a problem, because you can have like a very straightforward error that says like, received HTTP 500 or so on.
Don't get me wrong. I'm not. Don't get me wrong. Like when I turn on TF log and someone's taken the time to, if I set TF log to say trace, for example, and someone has taken the time to do well-structured errors and stuff, and I get a sense of what's actually happening, I'm thankful. But
you don't
generally
want to do it.
speaking, yeah, I know I don't want to do it. Like I just want to return E. Like just let me return E. So anyways, that's another thing you'll see with the new plugin SDK. So anyways, they get down here. It's most of your code now is going to have a lot of this add error stuff. I find. I don't know about you, but that's what I found. And then
Yeah,
this is basically
we have a lot more like validation in the HTTP client as well.
Yeah.
So it's around like, you know, if a 400 comes back, we return a very specific error type that can then be handled.
Yeah.
Which does do away with a little bit of this. Like you wouldn't be checking if okay and so on and so forth.
This one's new as well. This one, this is an interesting one. Provider implementers will know this one well. Do I set or do I not set the ID? Right? So for a long time, there was a debate like, no, you don't set it in the provider, it gets set automatically. And now it's like, no, you got to set it now. It's like explicit, you have to set it. So the idea now is with the new SDK is you must set the ID value at all times when persisting items. And the reason why I say that is because in some cases you'll have an ID property on your struct, which you must have now. But back in the day, it wasn't always a necessity. You could always there's an API call in the old provider called set ID that you could call. And if you did that, everything was fine. It would write ID to the underlying state file, but you didn't have to have it in your object definition. But now you have to have an ID property and set it in order for it to persist. So this is something that's also different.
I would 100% support more explicitness in tools like this.
Yes.
Because like ID was one of those ones where it was like realistically, it was always implicitly required. And if you didn't include it, you would get into like weird edge cases.
Weird things would happen. State didn't get persisted or it did or whatever. Yeah.
Yeah, it's like one of those like, you know, you get hit on the knee with a hammer and like your arm goes like this. You just couldn't explain why it was happening.
This is another thing that's interesting about this now, because remember how we talked about earlier about the protocol, the fact that we're exposing now the protocol more and more to you now it's like right in your face. So what we're defining here is a response. So this is again for the create operation. You get a response object as part of this call. You have to explicitly set the state back on the response that you're sending back. If you were watching this in a proxy trace, like if you were watching the protocol buffers fly back and forth, et cetera, and you were doing this via gRPC, which is the protocol for Terraform, you would see this response fly across the wire here. So you have to explicitly set the state in order for it to persist now. That's different. Before, you'd have to just set the ID and everything would just magically happen. Now we've got a different way of persisting.
Yeah, the one thing I like about this, again, is that you're explicitly setting the state, as opposed to previously where you would usually call a read operation, and then inside of that read operation, you would have explicit sets, which
I hated that. I hated that because I would always do a double call on my API. The way our APIs are written in Octopus is that I would have to do a double read over HTTP, and I didn't want to do that. So you see that a lot with people. They'll do a create and then they'll do a read. It's like, no, on the reply, I already got the persisted state. I don't need to do a read again. So we had to kind of change that pattern. But sorry, I interrupted again.
No, that's all right. It's one of those things. Like we have a couple of resources in the Cloudflare APIs where it creates a resource, but it's not actually usable for like half a second or a second.
Right.
Later.
Okay. Yeah.
And in that case, we still have to do the double read because like you do the post or the put or whatever it is.
Yes.
But then you still need to check that state after the operation is complete as well. Yeah. So I think that was where it was intended to be used. But yes, in most cases, you want to call read and you want to do it, but it's a very less than ideal situation to be doing multiple HTTP calls. Yep. Get the same data in 90% of the cases.
So here's a read. This is using very canonical type code. You're reading into a data structure. This is basically, you'll come to this point where you basically say, this property is that value, this property is this value. So there's this types collection, sorry, not collection, but types module that we talked about. And there's this string value types that you'll use for reading in these values. There's for all the base types that they expose, and you'll have this sort of mapping that occurs against the data structure. And then you have to set it again for the read operation. Updates, deletes, they all kind of follow this same pattern. Like you define your schema, et cetera, away you go, perform your update, and then set the state. And so once you get the handle, it's kind of like learning the piano. Once you learn the basic chords, you're kind of like, okay, I got it. Like it's okay. And then so here's the delete. The delete is a bit of an exceptional case because the ID is not being explicitly set, which means, and if you're not returning an error and the ID is not set, then the state comes back basically as nothing, basically. And in this case, it's like, yeah, the delete did in fact occur. So you're good to go from there.
There is a way of explicitly removing things from state, but it's one of those things that they say shouldn't be necessary for the majority of cases.
Yeah. There's a section here on managing private state data, APIs for that. I can't see myself wanting to do this other than with secrets. I think secrets would be the only exception when you want to basically store something to state in a certain way, maybe.
I feel like this is going to be one of those foot guns for this library.
Yeah. Okay.
Is people pulling things directly from like private state, as opposed to having the attributes match a one-to-one and doing logic around that.
Another thing that people typically do with CLI, the Terraform CLI, is they'll import. So defining an import state method is important if you want to support that. It's pretty much boilerplate based off the ID, so you can support that pretty easily. If you want to do multiple attributes, as they talk about here, did you do multiple attributes, or do you just do the ID lookup thing?
For import, we have a mixture of both. So we have, like, it's a little bit annoying, but like, for example, with access applications, originally they were launched at like the zone level and had like zone level entitlements, and then or like proxied through to the account level or something like that. But then what ended up happening is they're like, no, this makes sense at the account level. So for a long time, people were able to set them at the zone and the account level. So we needed a way of determining whether it was a zone level resource they wanted to create or an account level resource they wanted to create. It made life very interesting, and we're still sort of like unpicking it in the provider.
Which resource was that for?
Any of the access ones. I think access applications probably a good one.
And then I assume in your docs you put the import down here. So you got, I see, you got a tuple here, so you can say
nice.
Account ID.
That one's actually that one's account only now. But like there are others, maybe like access group or something. But yeah, the format we basically just output as the level and then like the identifier.
Yes, that makes sense. Yep, that makes sense. Speaking of, I know we're kind of jumping around here, but speaking of docs, you're using the TF Docs plugin, which everyone loves, for generating your docs. Is that correct?
I am. I also love it. We recently converted like all of the resources to it finally. It's just a big task to do for one person. But now the good thing is that like we have an internal product content team. So what we can now do is say, hey, like you update the schemas, it automatically regenerates and just ends up out there. We're also looking at things where we have examples in the Terraform provider and pulling those into other repositories.
Good.
The other thing that I do want to note with this, and I have a bug open or an enhancement, I guess, for the plugin framework, is that you can't modify all of one type in a schema in a certain way. Okay. So previously I would have things like if it was a force new or something like that. In the SDK v2, I had a condition that said like emphasize modifying this will cause replacement of the resource or something like that. So if someone was looking at the docs, it would be very clear that like modifying things, we're going to recreate it. And you can't do that at the moment with the plugin framework in the same automated fashion. It's just not there. So that's my only issue with the framework at the moment when it comes to doc integration.
Okay. Yeah, I just run the tool to generate the markdown files and away I go.
Yeah, and for most people, like that's totally fine. The part that like I was struggling with was when we wanted to customize things. And like, yes, you can run your own fork and whatever else, but like when you start getting into like, for example, we had it with defaults, we had it with like forcing new values, we had it with like conflict values, all these different sorts of conditions that like the plugin docs provide it as a part of the attribute, but they don't give you any more insight into it. So like, you know, forcing new, that doesn't come up on there, but like the same with defaults. Like, how do you know what the value defaults to if it's not in the documentation?
Right. Okay. I like it. What else should we talk about? There's a whole bunch of things, obviously, but validation, it's about this. It's roughly more or less the same to me. It's just the way it's structured is a bit different. I don't know if you have any comments about validation at all.
Yeah, about the same. It's just more Go-like. I thoroughly enjoy this approach. Because like I said, it's explicit and you know exactly, like when you write custom validators now, you have like the example there, like it has a really nice description, it had to convert it to a string and like all these different sorts of things. It's no longer just like write a function that returns a boolean whether or not it correctly validated or not.
Yep. They have a section on migrating, which is what we're kind of talking about, which is nice. They talk about obviously the benefits of moving to the new plugin SDK. I love the comparisons because when you look at these, you're like, oh yeah, I get it. And then you go down to what's new, you're like, oh, I totally want that now. And so it's almost like a sales pitch when you read it. It's like, oh, I get it. And then like I hated this stuff in the provider SDK v2, like this whole set string stuff. And now it's like more explicit when you come here and you're setting values. It just uses the struct tags and away you go. And I'm like, yes, like I don't have to do this stupid d.get stuff, like I hated that for the longest time. But yeah, this would be a good doc, maybe if you're at all interested about reading, like why would you go to the new plugin framework? This might be a good doc to kind of, if you're at the technical level, to go through.
It's also good as a reference, like
yeah.
I know the bug that like we keep hitting it around like the 0 values is an example in here where it's like, oh, you can do like get okay and get okay exists and like use a boolean.
Oh,
and,
I know,
like,
yeah, that's awesome.
And you're like, no, you don't have to do that. You just do like is null or has been nullable or something like that, which is quite nice.
Yeah, I agree. The whole get okay or has state or all those API calls you do off the D type would just be like, yeah, I don't want to do all this stuff. I hated this. This whole like all this stuff, and then the D properties and the functions that were there. You're just like, yuck, I don't want to do that anymore. So yeah, good. Was there anything else you wanted to cite or mention or highlight relative to the plugin SDK?
Not really. So just around the migration, the tips I would probably give people is like, one, use something automatic for your documentation. It makes life so much easier.
TF plugin docs, 100%.
Yep. The other one is around test suites. Make sure you have a good test suite. So that, oh, there you go. They even tell you migration.
Yep.
the test suite in 90% of the cases is what's going to get you where you need to be. So if you have a bug or like you have a regression, add tests for it. It makes your life so much easier when you're doing these sort of migrations. And knowing like Terraform and the internals of it, it's like writing a test now, it's going to take a little bit of time, but when you go to migrate to another tool or like they pull out the plugin for logging or something like that, which they did, it makes life a whole heap easier to know where the problem is actually happening. Because like do you use the
TF log library, by the way?
Where possible, yeah.
Yeah.
Okay. And the reason for it is like it's actually usable as a log drain. It's not just like standard error or standard out or whatever it ends up as. Like you can filter it and you can say, I don't actually care about like all of these core things that are happening. I'm debugging a provider level issue.
Cool. So just to highlight again, the Terraform provider for Cloudflare is up on the registry. Not to brag too much, but oh, look at that. You just crossed 35 million as we were talking here. Look at you. And then and this is where it gets embarrassing for me. This is the Octopus deploy one. We're at a paltry 800,000. But they're both available up on the Terraform registry. And have you guys fully converted over to the new plugin SDK now with the Cloudflare provider?
No, so we're only on the SDK v2.
Yeah, so likewise.
Yeah, but we have like swapped to all of the multiplexing.
Okay.
So like the possibility of someone adding a new resource in the framework is there.
Yeah.
We're currently in the process of evaluating what a migration is going to look like.
Okay.
So the verbosity for us is like a bit of a pain because we're like copying over and like trying to make all that sort of right. So we're getting a little bit into like how can we optimize that side of things and make that a little bit easier for future adventurers. And then like the other big thing that's on my plate at the moment is the 4x release. And as you can see, doing the release candidates at the moment.
RC1, RC2, RC3, R4.
Yeah. So like there's which is actually another little plug for the Terraform folks. If you do,
and for Semver, you should use Semver, right? Yeah.
Yeah. If you do something like Dash as a pre-release or something like that, it doesn't automatically get selected with all of the broad version selectors.
Yeah.
So
they do Semver right.
Yeah. So like to use 4.0.0 RC1, you have to explicitly say that's the version you want. You can't do like ~4, like it doesn't work, which is really, really good.
Yes, I agree. That is good. All right, so up on the registry, if you want to check it out, just another side note, obviously, is mentioning the fact that you've got your GitHub repository. So that's at Terraform Provider Cloudflare. Ours is available up on our labs org, which is Octopus Deploy Labs. Apologies, just watching how sausage is made. Here we go. And our provider is listed there. And that's the one that is also up on the registry. So you can take a look at that one if you're so inclined. And then obviously the docs, the docs are actually quite good. So if you're looking at getting your hands dirty with the plugin SDK, the docs are obviously, there's a migration doc that we just highlighted here. Obviously a great reference for you to check out. Unfortunately, we are in that stage where not a lot of people have done this. So that's why I wanted to talk to you, Jacob, share some notes around our learnings. This dropped, the new plugin SDK dropped in November, if I remember correctly. And since then, not a lot of people have migrated over. There are some smatterings of it, like the AWS provider, which is maintained by HashiCorp, has obviously been it's doing multiplexing now, at least from the source code that I've seen. But I haven't seen anyone convert anything over en masse right now. So I guess it's kind of a wait and see. Hopefully this helps you guys, those of you watching this video who are maintaining providers. If you have any questions, you can hit me up or you can hit Jacob up. I'm sure Jacob will be like, that's a problem for HashiCorp. Don't worry about it. But I'll be like, no, it's good. It's good. I probably can't speak as authoritatively as Jacob can around the provider stuff itself. But we're just two guys trying to figure this out, and hopefully this video helps. Is there any advice or any parting words you have there, Jacob, before we wrap up this video?
No, nothing for me. It's I think we've covered everything I was after in this one and more.
All right, perfect. Well, thanks a lot. Appreciate you guys' attention. You guys, can't believe I said that. And check it out. Start using the plugin SDK. I'm sure you'll see the benefits that we have so far. So take care.